Good morning. Let us start the new session, the new unit, unit number 2 of this subject, mechatronics. The syllabus for this second unit, that is block diagram representation, is you need to understand the concept of open and closed loop control system, identification of key elements of mechatronic system and represent it into a block diagram, electromechanical system specifically. So we had already discussed the key elements of mechatronic system. Then the important point is we have to represent it in the form of block diagram. Then we have to discuss the concept of transfer function, which is very important one as far as this particular unit is concerned. Then block diagram reduction principle, various principles, and application of mechatronic system in household, automotive, shop floor, and industrial. So this is the syllabus prescribed for unit number 2. The objective of this unit is to understand the key elements of mechatronic system and represent it into the block diagram form and understand the concept of transfer function, and you must able to reduce the block diagram. The outcomes will be identification of mechatronic system and representation into block diagram form. The assumed knowledge, the prerequisite for this is engineering mechanics, somewhat you know, and engineering mathematics 1, 2, 3. If you are basing knowledge of like Laplace transform, the fundamentals of Laplace transform, then it will be easy for you to gain the knowledge. These are the reference book. Now, what is control and what is control system? So the control system is an integral part of our daily life. Okay, it play a very important role. Like from if we consider a simple bread toaster to a complex power plant, we are having control system all around us, and it's a inseparable form of our modern society. Okay, but some of the commonly used, if we want to take some commonly used control systems in our day-to-day life, is washing machine. It's a control system. Simple. It's very well. Heater that we use, it's a control system. Bread toaster, it's a control system. Okay, so that is what we call a control system. If we take an if we want to represent any system, so this is one system. This is having input and this is having output. So this system must be controlled. So if it is controlled, then we will be getting input with respect to output. So all these control systems which are designed by human, we must realize that we are not only the creators of the control system. We are not, although we consider all these control systems, we are not the only creator of the control system. God is the best creator to control system. Our body, human body, is the best control system. If we consider, the controller is brain. When there is a hot season outside, we can our body sweats and thereby releasing the temperature of the body, thereby maintaining the temperature of the body. So that is how the control system works. So based on that, how can we define a control system? A control system is an arrangement or combination of some of the physical components, is an arrangement or a combination of various physical components called as subsystems, called as subsystems, connected with each other in a such a manner as so as to attain certain objective. So what is control system basically? These are the various elements or subsystems connected with each other in particular sequence to have some input and to get some output. That output will be your objective. So that is what we call a control system. It's a combination or arrangement of subsystems in a particular fashion to attain certain objective. So these control systems are having associated inputs and output. What are the functions that are performed by the control system? For a particular input, the system output can be controlled to a desired value. That is the function performed by the control system. Apart from that, if some conditions are satisfied, it can give a particular sequence of events as output to the corresponding given input. Okay. For example, for the first function, for a particular input, the system output can be controlled to a desired particular value. I am having the furnace in which the thermocouples are used to control the temperature. If I am giving input, let's say 70 degrees Celsius, so the output must be within the range of 70 degrees Celsius only. For a particular input, the system output that can be controlled to a desired value. So if I'm giving some input, my output, forget about input, my output, if I want it to be maintained at 70 degrees Celsius, that can be maintained with the help of your controller. Like in automobile, I want to control the temperature of the vehicle or the inside cabin temperature to 25 degrees Celsius, I must get that output irrespective of whatever the outside environmental condition. That is called as one of the function of the control system. Controlling the system output to a desired particular value. Second, if some conditions are satisfied, it can give a particular sequence of events as output corresponding to given input. For example, in our washing machine, in our washing machine, first we put the detergent and the water from the inlet. Okay, so if and the electricity obviously. So if we have these three inputs, then the particular sequence of events occurs. Like first is soaking of the cloth, second what we can say spinning, then drying, etc. So this particular sequence of the operation is performed to the given input. So these are some conditions must be satisfied. Like we must have water, we must have electricity, and we must have detergent that is placed inside the that particular box. So these conditions, if are satisfying, a particular sequence of event is performed and we'll be getting the output as clean clothes. What is the output? We'll be getting the clean washed clothes That is the function, another function of the controller. So what is the takeaway from this slide? What is control system? It's a combination of various subsystems connected in a such a way that it will give or it will attain some desired objective. Second, the control system performs the following functions, like for a particular input, outputs must be controlled to a desired particular value. And if another function is, if some conditions are satisfied, it can give the particular sequence of events as output corresponding to the given input. Controllability, since it is not in syllabus, but it is important to understand. Before the controller is implemented, it is necessary to test the controllability of the system. Controllability is the ability of the system to be controlled or provide desired performance provided an external disturbance is available. Okay, so that is what we call controllability, whether the system is capable to control or to provide the desired performance, to give the desired performance as expected from the system, provided that an external disturbance is available. Your air conditioner inside the room, outside temperature, whatever the outside temperatures available, those are the external disturbances. The fluctuations in the outside temperature are the disturbances which are implemented on the air conditioning system. But the system must be able to give whatever the temperature set inside by the user. So that is what we call controllability. If that particular air conditioning system is capable to maintain the temperature at a desired value or the input value, then the system is called as having good controllability, irrespective of the external disturbances. So that is called as controllability. Before going to the details of open loop control system, we must understand what is we must consider one example of a bulb that will make your ideas clear about the control system. So what is, if a simple bulb that we used in our house, what is the input for that bulb? The input is 230-volt AC power. And what is the output from that bulb is the light we are getting. So we have to define this. Input, what is input? What is input then? Input is an excitation or stimulus. It is an it is an excitation or it is a stimulus that is provided to the system from an external source in order to produce the output. What is input signal? Excitation or stimulus provided to the system from an external source to give an output. Here, in case of bulb, the input is power. What is output? What is output? It is the actual response obtained from the system. It is, what is output? It is an actual response obtained from the system. Here we are providing input through the bulb and we are getting the output as light. Then comes the term control. What is the meaning of control? It means to regulate, direct, or command a system, or command a system is called as control. Then comes the term control action. What is a control action? Control action is that quantity responsible for activating the system. It is a quantity responsible for activating the system to provide the desired output. That is called as control system. So a control system in all must be having an input, an output, and an arrangement of some subsystem to achieve the input output combination. It must have arrangement of subsystems to achieve input output combination. This is very important point to remember if we are going building further on control system. And mechatronics and robotics is nothing but the control. That's all. We are having input, we are having output, and we have to control the various actions. That is called as controllability, or in brief, the control system. Moving forward, open loop control system. In open loop control system, in which it does not automatically correct the change, or output is dependent on input, but the controlling action is totally independent of the changes in output. This is very important point to take down, as controlling action is totally independent of the changes in output. That is called as open loop control system. So though there is no feedback is used, and the controller must independently determine what signal to send to the actuator. So here, from the actuator, the controller is not getting any information regarding what is the position, or what is the quantity, or what is the magnitude of the output that the actuator is receiving. So the controller must have to independently determine what send signal that needs to be sent to the actuator, since there is no feedback is used. So here you can see that there is a plant. Plant is what? Plant is the system on which we are taking the action system. Like in the previous case, plant is bulb. Okay, washing machine is a plant, which is the mathematical model of input amplifier, actuator plus physical system. So this is a physical system. Plants means a physical system. Input means reference in or desired input or a set point value. Okay, so that is what we call as input. It's a reference or desired input or a set point value. Output is the measured output, the objective that we need to attain. That is what we call output. And the control law is the most important. It is a mathematical model of the controller to achieve the correct input output combination. That is what we call as a control law. So this is the block diagram of an open loop control system, in which there is a plant on which the control law is applied, and the plant is giving the output, and we are supplying some input. Here, the controller must have to independently determine what is the signal that needs to be sent to the output. So it is the system, it is a control action which is totally independent of the output. That is what we call as your open loop control system. So we are having, let us consider an example of a fan. If we switch on the fan, it start moving at a speed depending on the position of the regulator. If it continues to rotate at the same speed without taking into account the surrounding environment, then there is no way out. For example, if I'll explain it with the help of a block diagram. A simple fan, a ceiling fan. So a ceiling fan, a controller or the controller is regulator, and the system or the plant is a fan. We're getting some output. What is the output? Output is rotation of the fan in particular RPM, and input is our electricity. So here you can see that this regulator, if we set at certain speed, the fan continues to rotate at that particular speed, irrespective of external disturbances. This is very important. External disturbances. Like if there are chilly nights, so and the fan is at a very high speed, whether the regulator itself reduce the speed of the fan? No. There is very hot outside and the room is heating like anything, and the fan is rotating at a lowest speed. Will the regulator knows that the external disturbances are there and he has to increase the speed? No. That is what we call the open loop system, control system. There is a control action which is totally independent of changes in output or external disturbances. So that is what we call as open loop control system. But if we interface the human with this system, HMI, human machine interface. So what happens in this case? This will be a closed loop control system. Suppose I am sitting in my cabin and there is a very hot outside, and like in the March or April, and the temperature is very high. In that case, if the fan is rotating at low speed, I'll go over there, I'll rotate the regulator, and I'll increase the speed of the fan. So in that case, the system is closed loop. But forget about the closed loop control system time being. Open loop control system is, you remember that the output is totally independent on the changes in output, or that is what we call as open loop control system. Another example. These are the few examples: light switch, light lamp filament, or glass bulb. Okay, again we'll take this. If this is a control system, one of the simplest one, if we switch off the light, it is expected that from the light that it should give light, it must glow. But if what happens if this lamp is fused, if this lamp is fused, what will happen? It will not glow. It will not glow. In that case, is there any arrangement that this controller, that is this switch, will automatically take some corrective action? No. The controller only knows that the switch will be only two positions, on or off. In on condition, irrespective of whether the light is glowing or if it is fused or it is not glowing, the switch continues to supply electricity to the light. But the questions come that whether we are getting the desired output or not, or whether the objective is satisfied or not. That is the question remains. That is why it is called as open loop control system. Fine. Second control system. This is a tank in which some water level is maintained, and we are having hand wall. So if someone release that hand wall and the water continues to enter into this water tank, After the tank is filled, whether there is any arrangement that this hand valve will closed automatically? No. Irrespective of whatever the water level are attained inside the tank, the system is continuously giving the output. That's why it is called as an open loop control system. Another best example, hand dryer, electric hand dryer. You might have used these hand dryers in the malls and multiplexes. So this is a system, electric hand dryer. What is the input to the system? The input to this system is some electric signal. And what is the output? Expected is the dried hands. Okay. But if we put the already dried hands inside the below the dryer, that dryer will again operate. It will force or it will release the stream of hot air, irrespective of whether my hands are dry or wet. This dryer doesn't know, or the control law doesn't know what is the output that I am getting. Another case, if my hands are completely dry or not, it is not traceable by the dryer. That's why it is called as open loop control system. It sends a gush of hot air when the hands are taken near to it. The input to this is wet hands and output is dried hands. But the control action is nothing to do with the status of the output. How much my hands are dried, whether they are dried or not, or even if we place dry hands below the machine, it will generate a whirl of air. That's why it is open loop control system. Objective or the output, whatever, it is not controllable, or it is not instead of saying controllable, we can say it is not traceable. So that's why it is called as open loop control system. This is one example. Second, automatic washing machine. You must be amazed why I am taking this example. You must be saying that automatic washing machine is a closed loop control system. It is automatic one. But no. What is we have to consider what is input and what is output to the system. So the automatic washing machine, what is the output? Output must be clean clothes. Okay. And the input is your soiled clothes, the dirty clothes. This is the input to the system. Fine. Is there any arrangement to detect whether the clothes are soiled or clean? No. We can consider soap or electricity and water also input. And the control action is totally dependent on the timer. For the particular input, for 10 minutes it must soak, after 10 minutes it must spin, and then for 10 minutes it must dry. But the control action has nothing to do with the actual status of the clean cloth. I repeat my sentence. The control action has nothing to do with the status of the clean clothes. Like if I put the clean clothes itself into the washing machine and operate the washing machine, the controller will still operate, or the washing machine will still operate, or whether it will say like your Alexa that no, the clothes are already clean, I won't, I'm refusing to clean it. No, it won't happen. Irrespective of whatever the status of clean cloth, the machine will operate. It still washes it. If the perfectly clean clothes are also put into that, it will still wash it. Okay, and that's why it is called as automatic washing, or it is called as open loop control system. Next example, bread toaster. Bread toaster. This is a toaster. What is the input to the bread toaster? It is heat along with the bread. It is heated inside the toaster, and the output is toast or toasted bread that is expected. Totally depends on the time taken from converting the bread to a toast. The amount of toasting or the amount of amount of testing is dependent on time. So it simply heats the bread for some time. The time is determined for whether the bread is soft or hard toast, and that is calibrated. But in this case, the control action has nothing to do with the status of the toast. It has nothing to do with the status of the toast. Whether it is burnt, it is untouched, or it is no bread in the toaster. This is the height. No bread in the toaster. Whether the toaster takes some action, if the bread is burned, if it is untouched, I mean it is not at all heated. Although if there is a no bread in the toaster, still it will operate. Thereby, the status of the toast is not monitored. It is not rectified. So that is why it is called as the bread, or it is called as an open loop control system. T. Another example, automatic coffee or milk machine. Automatic coffee machine. So it is, what is, how it is working? It is ready coffee, which is prepared by the fixed proportion of ingredients, and it is asked simply to release when it is asked. It is assumed that the coffee cups are placed currently, but it does not ensure whether the fixed volume is filled in the cup. Hence, the system is aimed to send a fixed volume of liquid or whatever the beverages are there upon request. Okay, so it is assumed that the cup is placed. This is the machine, and below that the cup is placed, and it will simply release a fixed amount of beverage into this cup. It will not ensure whether the cup is placed or not. If simply we press a button over here, it will release it, irrespective of whether the cup is placed or the container is placed. The objective is to just release the coffee. Is there any case in which the coffee machine refuse to release or dispense the coffee just because you are not put the cup in below that? It's not the case. That's why it is called as an open loop control system. So these are the few cases or few examples of open loop control system. Again, we go back and we'll read these sentences again. Output is dependent on input, but the controlling action is totally independent of the changes in output. There is no feedback use, and that's why the controller must independently determine what signal to send to the control actuator. See this example once again. The light bulb, it is fused or not, no action taken. Whether the tank is filled or not, no action taken. Hand, whether the dried hands are there, whether the hands are dried properly or not, no output traceable. Status of the clean clothes, not detected. Status of the toast, not detected. Status of whether the cup is placed or not detected. So that's why these are called as open loop control system. But the specialty I want to mention over here, please pay attention. HMI, human machine interface. Now try to relate or try to include a human into all these systems that we have studied now. Here, I'm switching on the lamp. If it is fused, I'll switch off and I'll replace the lamp. If the tank is overflowing, I'll close the hand wall. Electric hand dryer. If my hands are not dried properly, I'll again put inside the below the dryer and get it dried. Automatic washing machine. Why I'll be placing the clean clothes again into washing machine? I'll ensure that my clothes are dirty, they are soiled, and then I'll use the washing machine. I'll check the quality of the toasted bread or the quality of the toast, and I'll ensure that it will not burn or it is properly toasted. I'll ensure while using the coffee machine that the cup is placed at a particular location properly so as to get a fixed volume of coffee. So over here, whenever the human machine interface operates, the open loop control system can be used conveniently. So that is why we are using. You please note that. If I am saying that these open loop control system are hopeless, then why we are using? We use electric hand dryers, we use automatic washing machine, we use toasters, we use coffee machines. But why we are using it? Because these are equipments are made to have a HMI, human machine interface. That's why they are working very fine whenever they are installed to serve the proper objective. So I hope open loop control system is clear to everyone. Some of the advantages of open loop control system, they are very simple in construction. They are very low cost is incurred for the manufacturing. It is convenient to implement when the outputs is difficult to measure. Whenever we cannot trace the output, at that point of time, it is advantageous to use your open loop control system. The disadvantages are the controller never actually knows if the actuator did what it was supposed to. It is inaccurate. So it is not at all traceable. Controller said something, but whether the actuator is doing this or not, the proper thing or not, it is not traceable. Like, let us take an example. I'm the controller. I'm delivering some concept to you people through online session. Whether you are browsing on internet or whether you are watching my lecture or you are just on Facebook or Insta, I don't know. So that is what is the disadvantage of open loop control system. And advantage of closed loop control system is over there. The offline classes, I can see you, I can watch you, I can, by reading your face, I know whether you are getting something or not, or whether you are concentrating or not. So that is the disadvantage or limitation of open loop control system. It is unable to sense the environmental changes or disturbances. That is very true in case of open loop control system. Moving forward, the closed loop control system. So in closed loop control system, controlling action is dependent on the changes in input. Here, there is a control law, the plant or system output. A certain output is measured and it is placed over here. This part is called as comparator. So comparator compares the input signal and the output signal that we are getting. If there are deviation in the input and output signal, that deviation is called as an error. That deviation is an error. Depending upon the error signal, the control action or the controller will be getting this error signal, and depending upon the error signal, the control action is taken on the plant. That is called as the closed loop control system. Okay, so we can say that a system in which the control action is dependent on the output is called as open loop control system. Control action is dependent on the output or changes in output. That is called as open loop control system. The examples: human. If there is very cold outside, the skin temperature is the feedback is sent to the brain, and the brain will decide whether to put the warm clothes or not. Next, the second example. Here I am installing, I have mentioned this earlier, I have installed the wall or the human operator over here. So what happens because of that? The operator will see the height. The operator will see the level of the water level, the level of the water, and then he will take the action whether to open or close the wall. That is what we call as closed loop control system. Again, this is example of automatic closed loop control system. What is automatic closed loop control system? Here you can see that a sensor is placed, and the whatever the level the is achieved, height achieved, height of water level is achieved, is that signal is sent to the controller, and the controller is taking the control action. It will rotate, that action will taken place on the actuator, that is the wall, and the wall will take out the excess water. For example, if the level goes beyond certain predetermined level, then this input level is maintained. If it is going, if the tank is about to fill, the actuator will take the action and the excess water will be drained out from the outlet. That is what we call as automatic closed loop control system. I'll quote another example, some few examples of closed loop control system. So my first example that I'm quoting is automatic electric irons. Automatic electric irons. So here you must note that we are analyzing the systems. We are analyzing the various control systems, and simultaneously I'll try to put these systems into the block diagram. Okay, so what is an automatic electric iron? It regulates the temperature of the iron such that for a given cloth selection, the temperature must remain in a specified range. Okay, when the temperature falls below the range, heating is started, and when it is exceeds the range, heating is stopped. Thus, it is a closed loop system with respect to the temperature as a control action, which initiates heating or non-heating of the coil. That control action is dependent on the output temperature, and the thermostat which is inside that iron will continuously checking the output temperature, which is then fed back to the comparator, which switches the on or switches off the heater. So that is the principle of automatic electric iron. Now let us mark or let us draw the block diagram for automatic electric iron, or let us represent this electric iron in the form of block diagram. So here first block is the switch, which is responsible for making the heater on or off, thermostat or thermostat switch which making heater on or off, and that heater action is implemented on plant. Now what is plant over here? The physical iron is your plant. The output that I am getting is the iron temperature is an output. Now from here I am getting the information of the iron temperature, which is sensed by the thermostat. Thermostat is a transducer which senses this temperature, output iron temperature, and that temperature is then fed to the comparator. Okay, so this is what we call as comparator, and to this comparator we will be having some desired temperatures. This path is called as feedback path. Fine. Now let us work on this system. I have set a desired temperature for my linen shirt. The switch will first on the heater, and the iron will be heated up to particular temperature. When that temperature is reached, the thermostat will send a signal to the comparator, and the comparator will check whether the desired temperature is reached or not. For example, my desired temperature or input value is 70 degrees Celsius. If it is 60 degrees Celsius, then the switch is on. If it is 65 degrees Celsius, till the switch is on. Once it reaches to 70 degrees Celsius, the thermostat will sense it that the iron reaches to 70 degrees Celsius, and that temperature is compared with the input value. So there will be no error signal over here. Okay, when the temperature reaches, the switch will be automatically get off, and the temperature is maintained at 70 degrees Celsius. After some time, whenever the temperature falls by some 1-2 degrees, again the thermostat sense it, and the error signal that is of 1 degree is sent to the switch, and the switch will be make the heater on, and the temperature will be at 70 degree. So that is what we call as the closed loop control system. So this thermostat, it may be an RTD, it may be a thermocouple. So that is how the feedback control system works on. Got my point? This is the representation of automatic electric iron in the form of block diagram. This path is called as feed forward path or simply forward path, and this path is called as the feedback path. Okay, so this is one thing. Next is next example. I quickly finish. Second example is Sun Seeker solar system. So what is there in Sun Seeker solar system? To get the maximum benefit, you have to change the, what we can say, that particular panels, solar panels, so that the actual condition of the sun, position of the sun, is continuously tracked. So let us draw me a diagram. So you can say that this is a tracker, okay, and this is sun. So these are the rays of the sun. This is reference position, and here we'll be getting the position feedback, and we are having controller, and this controller will then operate the positioner, and that will goes like this, and this is my solar panel. So as per the sun changes its position, that feedback is given to the controller by some position sensor. The controller takes the necessary action, and the position of the solar panel is then changed according to the position of the sun to get the maximum output from the panel, so that the maximum energy from the sun can be utilized. That is what we call as a feedback control system. Some of the advantages: it is accurate since controller modifies and manipulates the actuating signal such that error signal in this system will be zero. It is self-correcting one. It senses the environmental changes and disturbances in the system. Some of the limitations are: it is complicated to design. It is costly, obviously, because of the more number of equipments are there. It is unstable since due to feedback, system tries to correct the error. So this I'll explain in practical sessions why the closed loop control systems are the unstable kind of system. So we have studied so far what is control system, what is control action, what is open loop control system with some examples, and closed loop control system with some examples. So these are the points which I want to put in front of you, because this is very important as far as your control action is to be considered. So that's all from my side. You can put your attendance into chat box and you can leave the session, but tell your friends that they must have to attend the lectures, else we'll take some action, serious action. Thank you very much for attending.